Welcome to this Maths Made Easy video on conditional probability and tree diagrams. To start with, let's take a look at tree diagrams. Now suppose we have two events A and B such that the probability of A, is equal to P and the probability of B is equal to Q. Okay. Well, a tree diagram for A and B would look like this. And we can see here, like we just defined, the probability of A is equal to P. So in that case, the probability of A complement will be 1 minus P. And the same holds for B here. The probability of B is equal to Q, as we defined here. So in that case, the probability of B complement will be 1 minus Q. And from this, we can define some probabilities. So the probability of A intersection B, well, that would simply be P times by Q. So we'd write that as PQ. The probability of A complement intersection B, well, that would simply be 1 minus P times by Q. Okay, so we'd write that as 1 minus P times by Q. If we had the probability of A intersection B complement, so the probability of A intersection B complement, this would be equal to P, so that's P times by 1 minus Q, so that's P times by 1 minus Q. And finally then, if we had the probability of A complement intersection B complement, well, this would be equal to 1 minus P times 1 minus Q. And we can see that here from these two branches, 1 minus P times 1 minus Q there. Okay, and that's for the probability of A complement intersection B complement. Okay, so that gives us everything we need there for tree diagrams. Moving on now to take a look at conditional probability. So conditional probability is the probability of an event happening given that a related event has already happened. So here, if we write the probability here, and we're introducing some new notation here, so we read this as the probability of B given A here, okay? And this means the probability of B given A, which is the probability of B provided that A has already happened. And we have the following formula for this. So this is the probability of A complement B here, probability of A intersection B, and this is divided by the probability of A, okay? So that gives us the following result there. Now, if B is conditional on A, then A is conditional on B. And in that case, the probability of B given A is linked to the probability of A given B. And we can relate that by the following formula. The probability of A given B is equal here to the probability of B given A times the probability of A. And this is all divided here by the probability, again, of this part here, B given A, times by the probability of A, plus the probability of B given A complement, times the probability of A complement there. Okay, so that gives us our result there, linking those two conditional probabilities. And finally, we can update our probability diagram here, or our tree diagram here, as such. Okay, and this just illustrates how conditional probability works. So for example, if we obtain A first here, so that's the probability of A, well in that case then, if we obtain B second, that's the probability of B, given that we already got A there. Okay, so in that case, that gives us everything we need there for conditional probability, and that concludes this Maths Made Easy video on conditional probability and tree diagrams.